Now for these questions here, we're multiplying a multiple of 10, so a number in the 10 times table. And this means that we can use mental methods to work these out. So for 7 times 60, because we know that 7 times 6 is 42, 7 times 60 is 420, because if we have one end zero in the multiplication, we need one end zero in our answer. Now 80 times 9. So 8 times 9 is 72, which means that 80 times 9 is 720, because again, if there's one end zero in the question, there's one end zero in the answer. And 9 times 80 has the same answer, because again, if we ignore our end zero, we have 9 times 8, which is of course the same as 8 times 9, but one end zero in the question means we need one end zero in the answer. Now let's multiply using the grid method. First we have 9 times 28, so we have a 2-digit number, and we can partition 28 into tens and ones. So 28, this 2 stands for 20 and this 8 stands for 8. So what we can do is multiply 9 by 20, then multiply 9 by 8, and then add up our answers. So on our grid, we want the single digit number on the left, and then our partitioned number, so 20 and 8, on the top. Now, for this box here, we're multiplying 9 by 20. Well, 9 times 2 is 18, so 9 times 20 is 180, because if we have one end zero in a multiplication question, we have one end zero in our answer. Now, for this box here, we're doing 9 times 8, which is 72. So the last step is just to add these two numbers together. And you might need column method for this, for the addition, but 180 plus 72 comes to 252. So that's the answer to 9 times 28. Now 67 times 9. So the multiplication is written with the 2-digit number first, but we do the same thing. We partition the 2-digit number. So 67 is 60 and 7. And we can multiply 7 by 60, then multiply 7 by 7, and finally add up our answers. So on the left of our grid, we want the single digit number in our question, and on top we want the partitioned number, so 60 and 7. Now for this box here, we're doing 7 times 60. That's 420, because 7 times 6 is 42, but then if we have an end zero in our multiplication, we need an end zero in our answer. And now, for this box, we're doing 7 times 7, which is 49. So the last step is just to add up what's in the grid. So 420 plus 49. That comes to 469, so that's our answer. Now let's multiply using the expanded column method. So first we have 57 times 7. We can write the question out with our larger number, so our 2-digit number on top and our single-digit number below. Then we need two answer lines, because we're going to multiply the 7 digits by 7 on our first answer line, then the 5 digit by 7 on our second answer line, and then finally we're going to add up our answer lines. Now for our first answer line, 7 times 7 is 49, but now for our second answer line, we need to write a 0 in the ones column. That's because we're multiplying the 5 that's in our tens. Now 5 times 7 is 35, so we can just add up our answer lines. 9 plus 0 is 9, 4 plus 5 is 9, and nothing plus 3 is 3. So 57 times 7 is 399. Now 75 times 8. So we set the question out in the same way, and we start by multiplying our ones. 5 times 8 is 40. Then, again, really important that we remember a 0 in our second answer line, because we're multiplying by the 7 that's in our tens. So now 7 times 8 is 56, and we can add up our answer lines. 0 plus 0 is 0, 4 plus 6 is 10, so 1, 0, and 1 plus 5 is 6, so our answer is 600. And now 68 times 9. 8 times 9 is 72, we need a 0 in our second answer line, and now 6 times 9 is 54. So now we just add up our answer lines. 2 plus 0 is 2, 7 plus 4 is 11, so 1, 1, and 1 plus 5 is 6. So 68 times 9 is 612. 56 times 6. We can set this out as a short multiplication, and we start by multiplying our ones digit. So 6 times 6 is 36, but because that's a 2-digit number, we need to write 36 as 36, so with the first digit above the next place value column along. Now we can move on to our tens digit, and 5 times 6 is 30, but we need to add what's on top. So 5 times 6 is 30, plus 3 is 33. And because we don't have any more digits to multiply, we can just write 33 in our answer line. So 56 times 6 is 336. Now 82 times 9. So we can set it out in the same way. 2 times 9 is 18, so 1, 8. And 8 times 9 is 72, but we need to add the 1 on top to make 73. So our answer is 738. Now here we have 7 times 39. So although the question is written with our single digit number first, we do exactly the same thing as we did with these questions above. We write the 2-digit number on top. So always with column multiplication, write the number with the most digits on top. And we can do that because with multiplication, order doesn't matter. So 9 times 7 is 63, so 6, 3. And 3 times 7 is 21, and 21 plus 6 is 27. So our answer is 273. Now for these questions, we're multiplying 3 numbers together. So we could do 4 times 7, which is 28, and then work out 28 times 9. But with multiplication, order doesn't matter. So we could start by multiplying the larger numbers together first. 9 times 7 is 63, and then we can take that answer, so take 63, and multiply it by the other number in our question. So multiply 63 by 4. 3 times 4 is 12, so 1, 2. And now 6 times 4 is 24, plus 1 is 25. So our answer is 252. Now 4 times 9 times 5. Now we could, like we did here, multiply the larger numbers together first. So 9 times 5 is 45, and then we can take that and multiply it by the 4. 5 times 4 is 20, so 2, 0. 4 times 4 is 16, plus 2 is 18, so our answer is 180. But we might have got this answer quicker if, instead of multiplying the larger numbers together first, we multiplied the numbers that make a multiple of 10. So 4 times 5 is 20, and because that ends in a 0, it's really easy to multiply that 20 by the other number in our question. So 20 times 9 is 180, because 2 times 9 is 18. Then if we have one and 0 in a multiplication question, we have 1 and 0 in the answer. Now 8 times 7 times 5. We could multiply the larger numbers together first, so 8 times 7 is 56. Then we can work out 56 times 5. 6 times 5 is 30, so 3, 0. 5 times 5 is 25, plus 3 is 28. So our answer is 280. But again, it would have been quicker to spot that 8 times 5 is 40, and 40 ends in a 0. So then it's really easy to multiply that 40 by the other number in our question, so by 7. 4 times 7 is 28, so 40 times 7 is 280. You just multiply 4 by 7, then if there's one end 0 in a multiplication question, there will be one end 0 in the answer. Now here we're multiplying by 100. 2 times 100 is 200. And the way to think about this is to ignore the end zeros. 2 times 1 is 2, but then if you have 2 end zeros in the question, you need 2 end zeros in the answer. Now 100 times 6 is 600, because 1 times 6 is 6, but then there's 2 zeros on the end of 100, so we need 2 zeros on the end of our answer. And 7 times 100 is 700. Again, we can see what's happening with the zeros. So this zeros trick is really useful, but note that it only works with whole numbers. If we're multiplying decimals by 100, we have to do something else. But for whole numbers, just count up the zeros, and that's what you need on the end. Now here we're multiplying multiples of 100. So 2 times 400 is 800. That's because 2 times 4 is 8, and then if we have 2 end zeros in the question, we need 2 end zeros in the answer. 700 times 7 is 4,900. That's because 7 times 7 is 49, so if you have 2 end zeros in the multiplication question, you need 2 end zeros in the answer. And 9 times 800 is 7,200, because 9 times 8 is 72, but there's 2 zeros in the question, so we need 2 end zeros in the answer. Now let's multiply by a 3-digit number using the grid method. So we start with 5 times 147. But we can break down 147 into hundreds, tens and ones. This 1 stands for 100, this 4 stands for 40, this 7 stands for 7. So on our grid we can write the single digit number in our question on the left, and then we can write the partitioned number on top, so that's 100, 40 and 7. Now for this box here, we're doing 100 times 5. That's 500 because 1 times 5 is 5, then if we have 2 end zeros in a multiplication, we have 2 end zeros in the answer. So 500 goes in this box here, and in this box we're doing 40 times 5. That's 200 because 4 times 5 is 20, and then if we have an end zero in the question, we need an end zero in the answer, so that's 200. And now 7 times 5 is 35. So to get our answer, we just add up what's in our boxes, so that's 500 plus 200 plus 35. We can use column addition for this, and that gives us our answer, 735. Now 389 times 3. Again, we're going to partition our 3-digit number. So this 3 stands for 300, this 8 for 80, and this 9 for 9. So we can write our single digit number, the single digit number in the question, on the left, and then our partitioned number, so 380 and 9, on top. Now for this box here, we need to work out 300 times 3. That's 900, because 3 times 3 is 9, then if we have 2 end zeros in the question, we need 2 end zeros in the answer, so that's 900. Now for this box we have 80 times 3, which is 240, because 8 times 3 is 24, then 1 end 0 in the question means 1 end 0 in the answer. So that's 240. And now for our last box, we need 9 times 3, which is 27. So if we add up our answers, 0 plus 0 plus 7 is 7, 0 plus 4 plus 2 is 6, and 9 plus 2 is 11. So we have 1,167. Now 7 times 229. We partition 229 into 220 and 9. We write the single digit number in the question on the left, and then our partitioned number on top, so that's 220 and 9. Now for this first box, we have 200 times 7, which is 1,400, because 2 times 7 is 14, and then if we have 2 end zeros in the question, we need 2 end zeros in the answer, so that's 1,400. Now for this box, we have 20 times 7, which is 140, because 2 times 7 is 14, and if we have 1 end 0 in the question, we need 1 end 0 in the answer, so that's 140. And for our last box, we have 9 times 7, which is 63. So if we add up our answers, 0 plus 0 plus 3 is 3, 0 plus 4 plus 6 is 10, so that's 1, 0, 1 plus 4 plus 1 is 6, and 1 plus nothing is 1. So our answer is 1,603. And it's the same here. We can partition our 3-digit number into 400, 70, and 6. We write our single digit on the left, then our partitioned number on top. Here we have 400 times 9, so that's 3,600, because 4 times 9 is 36, but if we have 2 end zeros in the question, we need 2 end zeros in the answer, so that's 3,600. On to the next box, we have 70 times 9. That's 630, because 7 times 9 is 63. If there's 1 end 0 in the question, there's 1 end 0 in the answer. And now for this last box, we have 6 times 9, which is 54. So we can add up our answers. 0 plus 0 plus 4 is 4, 0 plus 3 plus 5 is 8, 6 plus 6 is 12, so 1, 2, and 1 plus 3 is 4. So our answer is 4,284. Now let's multiply a 3-digit number by a single-digit number using the expanded column method. So we write our question out with the larger number, or the number with the most digits, on top, and here we're going to need 3 answer lines. That's because we have 3 digits in our number. So for this first answer line, we're multiplying the 1's digits, and 4 times 2 is 8. Now we can move on to our second answer line, but it's really important that we remember to write a 0 in the 1's digit of our second answer line. And that's because we're now going to multiply by this 6, but this 6 is in our tens place, so we need a 0 in our 1's. Now 6 times 2 is 12, and we can move on to our third answer line. But here we're going to need 2 zeros, and that's because we're next going to multiply by this 5 in our hundreds. But because it's in our hundreds, we need zeros in our tens and our 1's. Now 5 times 2 is 10, so the last step is just to add up our answer lines. When we do that, we have our answer, 1,128. Now 929 times 5, so we can set the question out in the same way, and again we start by multiplying our 1's. 9 times 5 is 45, so on to our second answer line, we need a 0 as the last digit. We need a 0 in our 1's because we're now multiplying the tens digit. 2 times 5 is 10, so we can move on to our third answer line. But we need 2 zeros at the end. We need zeros in our tens and 1's because we're multiplying by our hundreds digit. 9 times 5 is 45, So now we just add up our answer lines and we get 4,645. 297 times 6. 7 times 6 is 42. We need a 0 at the end of our second answer line, and now 9 times 6 is 54. Now we need 2 zeros on the end of our third answer line, and 2 times 6 is 12. So we add up our answer lines, and our answer is 1,782. 157 times 5. So we can set this out as a column multiplication. We start by multiplying the digits in our ones, and 7 times 5 is 35. Now 35 is a 2-digit number, so we need to write the first digit, the 3, up here, so to the left, and then the 5 in our answer line. Now on to the next digit. 5 times 5 is 25, but then we need to add the 3 that's on top. So 5 times 5 is 25, plus 3 is 28, so 2, 8. Now on to our last digit. 1 times 5 is 5, plus 2 is 7, so 157 times 5 is 785. Now 976 times 4. So we can set the question out in the same way, and again we start by multiplying the digits furthest to the right. So 6 times 4 is 24, so 2, 4. On to our next digit. 7 times 4 is 28, but then we need to add the 2, and 28 plus 2 is 30, so that's 3, 0. Now on to our last digit. 9 times 4 is 36, and then we need to add the 3, and 36 plus 3 is 39, which, because we don't have any more digits to multiply, we can just write in our answer line. So 976 times 4 is 3,904. Now here we've got 8 times 817. But remember, with multiplication, order doesn't matter. So here, it doesn't matter that the single digit number is the first number in the question rather than the second number as it was above. We do exactly the same thing. We still set the question out with our larger number, the number with the most digits, on top. And we followed the same method. 7 times 8 is 56, so 5, 6. On to our next digit. 1 times 8 is 8, plus 5 is 13, so 1, 3. And our last digit. 8 times 8 is 64, and 64 plus 1 is 65. We don't have any other digits to multiply, so we can write the 65 in our answer line. So our answer is 6,536. Now for these questions, we're dividing a multiple of 10, so a number that ends in a 0, by a single digit number. And there's a trick that we can use here. If we look at these multiples of 10, but we ignore the 0, notice that 28 is in the 7 times table, 56 is in the 8 times table, 63 is in the 9 times table, and when we spot this, we can use mental methods to solve these. So 280 divided by 7 is 40, and that's because 28 divided by 7 is 4, but then if we have an end 0 in our dividend, we need an end 0 in our quotient. And for 560 divided by 8, our answer's 70, because 56 divided by 8 is 7. We know that because 7 times 8 is 56, but then if there's an end 0 in our dividend, we need an end 0 in our quotient. And we can do the same thing here. Our answer is 70 because 63 divided by 9 is 7, and an end 0 in the dividend means we need an end 0 in the quotient. Now it's really important to stress this only works because when we ignored the 0 we didn't get a remainder. So if it had been 520 divided by 8, the zeros trick wouldn't work because 52 divided by 8 doesn't divide exactly, it would give us a remainder. But here, taking this question, because 56 divided by 8 we spotted was 7, we can just put the 0 into our answer. Now for these questions, we're dividing a multiple of 100, so a number that ends in 2 zeros, by a single digit number. And if we ignore the zeros for a moment, we can see that 8 is in the 2 times table, 36 is in the 6 times table, and 45 is in the 9 times table. So for these questions, we don't need to use short division. Instead, we can use mental methods. 800 divided by 2 is 400, and that's because 8 divided by 2 is 4, because 4 times 2 is 8. Then, if we have 2 end zeros in the dividend, we need 2 end zeros in the quotient. 3600 divided by 6 is 600. That's because 36 divided by 6 is 6, and then we need our 2 end zeros. And 4500 divided by 9 is 500. That's because 45 divided by 9 is 5, then 2 end zeros in the dividend means we have 2 end zeros in the quotient. Now let's divide a 3-digit number by a single-digit number using expanded division. So we can write out 588 divided by 2 like this, with our divisor on the left. Now we take the first digit and we have 5 divided by 2. So we need a number in the 2 times table that's as close to 5 as possible but still less than 5. So the closest number that's in the 2 times table is 4, so we write 4 underneath the 5. And because 4 is 2 times 2, we write 2 in our answer line. Now we subtract and bring down. 5 minus 4 is 1, and we can bring down the 8. So we have 18 divided by 2. Now 18 is in the 2 times table, so we can write 18 under the 18, and because 18 is 9 times 2, we can write 9 in our answer line. Now we subtract and bring down, but 18 minus 18 is just 0, so all we need to do is bring down the last digit, bring down the 8, and we have 8 divided by 2. Because it's our last digit, we can just write the answer. 8 divided by 2 is 4, because 4 times 2 is 8. But if we want to show that we don't have a remainder, we can subtract 8 and get 0. So 588 divided by 2 is 294. Now 498 divided by 6, so we can write the question out in the same way. Now if we take our first digit, we have 4 divided by 6, but 4 is less than 6. So when the first digit is less than the divisor, what we can do to save time is take the first 2 digits together and divide 49 by 6. So we need to think what number in the 6 times table is closest to 49 but still less than 49. Well, 48 is in the 6 times table, and because that's 8 times 6, we can write 8 in our answer line. So now we just subtract and bring down. 49 minus 48 is 1, and we can bring down the 8, bring down the last digit, so we have 18 divided by 6. Now that's exactly 3, because 3 times 6 is 18. And because this 8 was our last digit, I like to just write the 3 in the answer straight away. But if you want to show that there's no remainder, you can subtract 18 and get 0. So 498 divided by 6 is 83. Now 651 divided by 7. If we take the first digit Again, 6 is less than 7, so it makes sense to take the first two digits together and divide 65 by 7. So we want a number in the 7 times table which is closest to 65, but still less than 65. Now 63 is in the 7 times table, and because that's 9 times 7, we can write 9 in our answer line. So now we subtract and bring down. 65 minus 63 is 2, and we can bring down our last digit, bring down the 1, so we have 21 divided by 7. Now 21 is in the 7 times table. 3 times 7 is 21, and because that was our last digit, we can just write the 3 in our answer straight away, because 3 times 7 is exactly 21. But if we want to show that there's no remainder, we can subtract the 21 from 3 times 7 and get 0. So 651 divided by 7 is 93. Now here we're dividing a 3-digit number by a single-digit number, so we can use short division. Taking the first digit, 5 divided by 2 is 2 remainder 1. That's because 2 times 2 is 4, then we need one more to get to 5. Now 18 divided by 2 is exactly 9, because 9 times 2 is 18, so we don't have a remainder. Finally, 8 divided by 2 is 4, because 4 times 2 is 8, so our answer is 294. Now 498 divided by 6. Now if we look at the first digit, we can see that it's less than the number we're dividing by, and when that happens, we can take the first two digits together. So instead of 4 divided by 6, we can do 49 divided by 6. That's 8 remainder 1, because 8 times 6 is 48, but then we need one more to get to 49. So now 18 divided by 6 is 3, because 3 times 6 is 18, so our answer is 83. Finally, we have 651 divided by 7. Again here, we need to take the first two digits together, because 6 is less than 7. So let's start with 65 divided by 7. That's 9 remainder 2, because 9 times 7 is 63, but then from 63 we need 2 more to get to 65. So now we have 21 divided by 7, which is exactly 3, because 3 times 7 is exactly 21. So our answer is 93. Now here we have some missing number multiplications. But for this first question, the missing number is just the answer. That's because it doesn't matter whether the equal sign is at the start or at the end of the calculation like it normally is, we do exactly the same thing. So we just need to work out 109 times 7. So we can use short multiplication. 9 times 7 is 63. 0 times 7 is 0, plus 6 is 6. And 1 times 7 is 7. So our answer is 763. Now we have 6 times something equals 732. So one of the numbers in our multiplication question is missing. And when this happens, we need to use the inverse operation, so we need to use division to find the missing number. Using short division, 7 divided by 6 is 1 remainder 1, because 1 times 6 is 6, then we need one more to get to 7. Now 13 divided by 6 is 2 remainder 1, because 2 times 6 is 12, but then we need one more to get to 13. And finally, 12 divided by 6 is 2, because 2 times 6 is 12. So our missing number is 122. And here, something times 7 equals 525. Again, whenever there's a missing number in a multiplication question, we use division to find our answer. Now for this question, if we look at the first digit, we have a 5, but that's less than the 7 we're dividing by. So let's take the first two digits together and work out 52 divided by 7. That's 7 remainder 3, because 7 times 7 is 49, but then we need 3 more to get to 52. Now 35 divided by 7 is 5, because 5 times 7 is exactly 35, so our missing number is 75. So here we have some missing number division problems, but for this first question, the missing number is just the answer. That's because we have our problem, and it doesn't matter whether the equal sign is at the start, like it is here, or at the end, like it normally is. We do exactly the same thing. So we just need to divide 591 by 3. So we can use short division. Taking the first digit, 5 divided by 3 is 1 remainder 2. That's because 1 times 3 is 3, and then from 3 we need 2 more to get to 5. Now we have 29 divided by 3. That's 9 remainder 2, because 9 times 3 takes us to 27, but then from 27 we need 2 more to get to 29. So finally we have 21 divided by 3. That's exactly 7, because 7 times 3 is 21. So our answer is 197. Now here we have 276 divided by something equals 6. So our divisor is missing. And what we do when the divisor is missing is just divide the dividend by the quotient. So if the divisor's missing, we still use division to find the missing divisor. So there's no point doing 2 divided by 6 because 2 is less than 6. So let's take the first two digits together and work out 27 divided by 6. That's 4 remainder 3, because 4 times 6 is 24, but then from 24 we need 3 more to get to 27. So now we have 36 divided by 6, which is exactly 6, because 6 times 6 is 36. So our missing divisor is 46. Now we have something divided by 7 equals 607. So our dividend is missing, and that means we need to use multiplication to find our answer. Remember, division is the inverse of multiplication. So something divided by 7 equals 607. You could read it backwards as 607 times 7, and that would give us our dividend. So we can use short multiplication. 7 times 7 is 49. 0 times 7 is 0, plus 4 is 4. And 6 times 7 is 42. So our answer, our missing number, is 4,249. Now we're going to answer these questions by chunking on a number line, but for these questions we're going to get a remainder in our answer. So for 97 divided by 3, because 97 is much bigger than 3, rather than counting up in steps of 3, we can count on our number line in steps of 10 times 3, so in steps of 30. So 10 times 3 is 30. If we add another 30, so another 10 lots of 3, that takes us to 60, and then another 10 lots of 3, so another 30 takes us to 90. Now 90 is close to 97, so now we're not going to count another 10 steps of 3 because that would take us over 97. Instead, we can just count up in 3s. So 3 more than 90 is 93, then another 3 takes us to 96. But if we jumped another step of 3, that would take us to 99, and that would be too many. Now to get to 97 from 96, we just need one more. Not one more step of 3, but just an extra 1. So that extra 1 is our remainder. So 97 divided by 3, we counted 10, 20, 30, 31, 32 steps of 3, but then we needed one more. So our answer is 32, remainder 1. Now 250 divided by 6. So again, we can count in steps of 10 times 6, so in steps of 60. 10 times 6 is 60. If we add another 10 lots of 6, so another 60, that takes us to 120. Then another 10 sixes takes us to 180, and then another 10 takes us to 240. Now this is close to 250, so now instead of counting in steps of 10 times 6, let's just add another one jump of 6. That takes us to 246. But if we jumped another 6, we would get to 252, but that would be too many. So from 246 to get to 250, we need to count on another 4. So that extra 4 to get from 246 to 250 is our remainder. So 250 divided by 6, we counted 10, 20, 30, 40, 41 steps of 6, but then we needed another 4. So our answer is 41, remainder 4. Now 195 divided by 8. So we can start by counting in steps of 10 times 8, so in steps of 80. If we add another 10 steps of 8, so another 80, that takes us to 160. But then from 160, if we jumped another 10 steps of 8, that would be 240, so that would be too many. So from 160, we can now just jump in steps of 1 times 8. So adding another 8 takes us to 168. Then 168 plus 8 is 176. Then another 8 takes us to 184. And another 8 takes us to 192. But we need to stop here, because if we jumped another 8, that would take us to 200, but that would be too many. So from 192, how many do you need to count on to get to 195? Well, 195 is just 3 more than 192, so our remainder is 3. So 195 divided by 8, we counted 10, 20, 21, 22, 23, 24 steps of 8, then we needed 3 more. So our answer is 24, remainder 3. Now let's divide using expanded division. But for these questions, we're going to get remainders in our answer. So first, we have 97 divided by 3. So we can set the question out as we normally do with our divisor on the left. Now, taking the first digit, we have 9 divided by 3. Well, 9 is in the 3 times table, and 9 is 3 times 3, so we can write 3 as the first digit of our answer. So now we subtract and bring down. 9 take away 9 is 0, so we don't need to write anything here, but we do need to bring down the 7. So we have 7 divided by 3. Now the closest number to 7 that's in the 3 times table and that's still less than 7 is 6. And 6 is 2 times 3, so we write 2 in our answer line. But now, when we subtract, 7 minus 6 is 1, and we don't have anything else to bring down, so this 1 tells us that we have remainder 1 in our answer. So 97 divided by 3 is 32, remainder 1. Now 250 divided by 6. Well, if we take the first digit, 2 is less than 6, so that tells us that we can take the first 2 digits together and divide 25 by 6. Now the closest number to 25 that's in the 6 times table but is still less than 25 is 24. And that's 4 times 6, so we write 4 in our answer line. Now we subtract and bring down. 25 minus 24 is 1, and we can bring down this 0, so we have 10 divided by 6. Now the closest number to 10 that's in the 6 times table but is still less than 10 is 6, and that's 1 times 6, so we write 1 in our answer line. But now when we subtract, 10 minus 6 is 4, and that 4, because we don't have anything else to bring down, that 4 tells us that we have remainder 4. So our answer is 41 remainder 4. 195 divided by 8. Again, the first digit is less than the divisor, so we can take the first 2 digits together and divide 19 by 8. The closest number to 19 that's in the 8 times table but is still less than 19 is 16. And that's 2 times 8 is 16, so we write 2 in our answer line. Now we subtract and bring down. 19 minus 16 is 3, and we can bring down the 5, so we have 35 divided by 8. Now the closest number to 35 that's in the 8 times table but that's still less than 35 is 32. And because 4 times 8 is 32, we write 4 in our answer line. But now, when we subtract, 35 minus 32 is 3. We don't have anything else to bring down, so that 3 tells us that we have remainder 3. So our answer is 24 remainder 3. Now for these questions, we can still divide using short division, but we're going to get remainders in our answer. So for 97 divided by 3, we can start with 9 divided by 3. That's exactly 3, because 3 times 3 is 9, so we don't have a remainder. But now for 7 divided by 3, we get 2 remainder 1. That's because 2 times 3 is 6, but then we need 1 more to get to 7. So 97 divided by 3 is 32 remainder 1. Now 250 divided by 6. So the first digit is a 2, and that's less than 6, so let's take the first 2 digits together and divide 25 by 6. That's 4 remainder 1, because 4 times 6 is 24, but we need 1 more to get to 25. So now we have 10 divided by 6. That's 1 remainder 4, but we don't have any more digits to write our remainder 4 in front of, so we just write as our answer 41 remainder 4. The remainder is 4 because 1 times 6 is 6, but then we need 4 more to get to 10. So 250 divided by 6 is 41 remainder 4. Now 195 divided by 8. Again, we're going to need to take the first 2 digits together because 1 is less than 8. So 19 divided by 8 is 2 remainder 3. That's because 2 times 8 is 16, but then we need 3 more to get to 19. So now we have 35 divided by 8. Well, 4 times 8 is 32, but then to get to 35 from 32, we need 3 more. So our remainder is 3. So 195 divided by 8 is 24 remainder 3.